In this problem, we're asked to find the exact value of the remaining trig functions of theta. If we're given that sine of theta is equal to square root 2 over 6, and cosine of theta is greater than 0. So what this tells us is which quadrant we're in. Based on this information, sine is positive, cosine is positive. The only place that happens is in quadrant 1. So if we think back to what we learned in class, all students take calculus as one way for us to remember the sign, S-I-G-N, of each of the trig functions. So if we look, sine and cosine, everything is positive in quadrant 1. So that tells us that we are in quadrant 1. So what we want to look at now is what we're given here in terms of sine of theta. Sine, we learned, is y over r. So it gave us a y value and it gave us an r value. So this means that y equals square root 2, and it's positive in quadrant 1. R is equal to 6, which is always positive. Our r value is always positive. So we need to figure out what x is. We know that x squared plus y squared equals r squared. X is what we do not know. We do know our y, so we'll square the square root of 2, and we know our 6. Our r value is 6. So we have x squared plus 2 equals 36. Subtract 2 from each side, and we get 34. Take the square root. Technically, we get plus or minus, but because we're in quadrant 1, we only take the positive value. So this gives us that x is equal to the square root of 34. So we will use this information and apply it to finding the other 5 trig function values. Alright, so what we want to do here is, like I said, we want to take this information here on the left-hand side and we want to apply it. So I'm going to move it down here where we can continue to see it. We want to look for sine, cosine, secant, cosecant, tangent, and cotangent. So if we're looking for that information, we were given that the sine of theta is square root 2 over 6. So we know that the sine of theta is square root 2 over 6, which goes with the information that we have over here, y over r. So its reciprocal is going to be cosecant of theta. The reciprocal gives us 6 divided by the square root of 2. We will rationalize that denominator by multiplying by square root 2 over square root 2. This gives us 6 square root of 2 over 2, which simplifies to 3 square root 2. So cosecant of theta is equal to 3 square root 2. So we have sine, which was given, and we just found cosecant. Now we want to go back and we want to find cosine. So cosine of theta is going to be x over r. So the square root of 34 over 6. That's going to give us cosine of theta. We'll box that in as our answer. The reciprocal of cosine is going to be secant. So we're going to find the secant value. So again, we'll take this information here on the left. I'm going to move it over to where we can use it, so we can refer to it. Give me just a second to get it moved over to maybe where we can see it and use that information. Alright, so what we're going to do here is use this information now to find secant. So secant of theta is going to be the reciprocal of what we found for cosine. So 6 over the square root of 34. So this gives us 6 square root 34 over 34, which simplifies then to 3 square root 34 over 17. So that's secant theta. Now we'll look at tangent theta and cotangent theta. So looking at tangent of theta, tangent of theta is going to be y over x, so square root 2 over square root 34. This will simplify. We can divide it out since they're both under a square root, 1 over square root 17. So tangent of theta is equal to square root 17 over 17. Again, that's after we rationalize the denominator. The last piece of information that we are looking for is cotangent theta. So I'm going to fit this in here. Cotangent theta is equal to the reciprocal, which is going to be x over y. So square root 34 over square root 2. And when we divide that out, cotangent theta is equal to the square root of 17. So the square root of 17 is what cotangent of theta is equivalent to. And that gives us our 6 trig functions. I apologize for how messy it is. If we look back at it, though, in each area, we can see where our answers came from, the fact they all turn out positive, and using x, y, and r can get us to these answers.